Hey there! In this video you will see how to connect your LangGraph agent with other agents through an A2A protocol. The new protocol that was recently introduced by Google. This protocol allows agents to talk to each other. Before it was also possible, but it was not standardized, so the idea of Google is to bring a clarity to this and make it easier for different organizations or different teams integrating their agents and basically having a single ecosystem where agents talk to each other and do the work. I will also show you how to combine A2A and MCP so that you can also see the difference. And for this we have a very simple app that does the weather check. And in order to get the weather information we use Travely, an online search engine that easily integrates with LLM. For example, we ask for the weather in San Francisco and it goes and talks to Travely and gets the search results and answers this question. So now it is 15 degrees, which is pretty similar to Berlin actually. The promise from Google, along with this protocol, was introducing a platform named Agentspace. It's a new version of their notebook LM for enterprise, but on steroids. So they also allow you connecting custom agents. And as I understood from their announcement, maybe I was wrong, for you to also double check, is that they will allow you to connect custom agents using this A2A protocol. And I already requested access to the Agentspace because currently it's not yet available in Germany. I think it's generally not available to everyone. You need to request the access. And once I will get the access, I will double check if it is compatible. But the idea is, as you understood, connecting different agents to your Google Workspace ecosystem and being able to do nice stuff in one single place. And because this thing is official, the protocol, and many players are already supporting it, soon we'll have lots of other players also providing their own interfaces to connect agents there. That's why it's very important to understand how it works and be able to deliver your agent in a A2A compatible way. Along with this announcement, they also shared a huge repo where they have lots of different examples of how A2A works with different agents and stuff. You can check it out later on. The thing we will take from here until we don't have access to a proper Agentspace is their demo web app that also allows connecting custom agents. I will skip the step instructions. You can check it out in the repo, but basically it's already running on my end and that's how it looks like. So when you run it first, it will ask you to enter the API key from Google. This is needed for Gemini because this example uses Gemini in this main agent that will be talking to different agents. Because the agent I will show you in this demo is just one of the agents that will be serving this main agent. If you come back to the architecture, you can also see this here. We are here now in the web browser and are looking on the front end. And the front end, under the hood, it has a host agent. And this host agent is driven by Gemini, and we can connect multiple remote agents to this host agent. So, the first thing you need to do is to enter the API key. And once you enter the API key, you can go to the agents and add a new one. When you use A2A, the only thing you need to enter in order for the agent to be discovered is the domain name of the agent, and then as per the protocol, it expects to have an agent card and under a specific address. These details you can check in the Google documentation they provide about the protocol. It's well described there, so you can just check everything here. But basically, once we enter this URL, it will discover the agent. And because LangGraph is not compatible with this protocol, it has its own API. What I've created is an adapter that basically proxies all the requests that are A2A compatible to the LangGraph server. And it looks this way. So we have an A2A client, which will be basically this demo host agent we will be running from Google, and it will be connecting to our LangGraph agent that is running on the LangGraph server through a LangGraph A2A adapter. The adapter I created, the repository and the instructions on how to set it up are all here in this repository. I will not be going too deep into this, but basically this thing converts A2A compatible communication into the communication that LangGraph expects. And this server, this adapter is already running on my end here, and it's running under this host and port. So if you just copy it and paste into the agent address field and click read, they have a bug. You need to enter the domain without the scheme. So not HTTP, etc., but just 4 zeros and then the port. So once you do this, it fetches the agent card, and from the agent card it discovers what is this agent about, what kind of stuff it can do, skills, etc. All these details you can find in the protocol, but basically we just click save. And now if we go to the chats, the conversations, we create a new one and we can ask the same question: what the weather in SF? Also, if we come back to the studio, so we can see now we still have our own old thread that was 9 minutes ago with the weather. If we will ask this question again, already through our client, basically here, and click send, it starts talking to the agent. Now if we see here, it also started the thread. And we get the reply. So this reply is basically coming back from LangGraph, from the agent we have here. It's also a bit edited because of the logic on this level, but the idea is that this agent was only able to do this by connecting the agent through this protocol. And this way you can connect many other agents, and the promise from Google, as I believe, is basically being able to do this in their agent space, which will speed up the things a lot and make everything much nicer in terms of the experience compared to what we have at the moment. The other things you can also check out here are the tasks, because this protocol exposes this term as a task, and agents can be given different tasks. And here you can basically see was it completed, what was the latest output, etc. You also have different events, what was actually happening, how the task was worked on, when it was completed. And this all is coming from LangGraph. And the way it currently works, so every task is an individual run on LangGraph, basically this thing. Every conversation which we have here is a LangGraph thread. In the context of A2A, it's named a session. So for example, if we will say something else, it will also go to the same LangGraph thread we have here, so you can already see. And it does the second run, which is basically the second task. And if you come back to the code, so if you take a look inside of the agent, it's pretty simple. It has a Travely server, which exposes an MCP server, the only tool which is the search to find something on the internet. It has the agent, the graph, and this graph is loaded asynchronously because first we need to pull the tools from Travely. Basically, I use the adapters from LangGraph, from LangChain, that expose MCP, like they create an MCP client and wrap it in a tool so that I can easily communicate with an MCP server. In this example, it's a part of the repository, but you can also check many other MCP servers that are available online and easily connect to them. For example, to the server from GitHub or from Notion, basically from any tool. There is a nice website where you can discover lots of different MCP servers So the idea is to basically reuse the logic that was already built by someone instead of every time creating your own tool, and focus only on the logic on your agent level. So if we come back to the repository, as I said, we have the server is accessed through the tools, and the tools are injected into the agent. And in the agent we have a tool node, which is basically the node that executes the tool and validates the outcome, and if something is wrong, it will retry the tool, and the actual agent node that decides what to call. This pattern you can also check on the website of LangChain. They have lots of examples of the way you can call the tools. And that's basically it. You will find all the instructions on how to set everything up locally in this repository, and the adapter you will find on my GitHub.